Hello everyone, welcoming you to Shourab's classes. And today we are looking at General Economics Paper 1 of IES 2022, question number 10, Part A. Graphically explain the Lorenz curve as a measure of income inequality. So, suppose now this is a very practical question. Now, suppose we have some data on a society. Let us say we have some income data on a society consisting of n individuals. And without much confusion, let's say they are arranged in ascending order, y1 to yn. Okay, and the individuals are numbered as 1 to n. So obviously the way I have written it down, individual 1 has lower income than individual 2 and so on. So if I tell you what is the total income of the society, you will simply add all of them up, so it will be summation I running from 1 to n yi, and total individuals in the society, that is n, right? Right. So now let us say we define two variables. Let's say fx. It's basically cumulative proportion of individuals having income less than equals to x. Now note one thing, if instead of individuals, even if you had class of individuals, that means f1 is the frequency of individuals having income by 1 and so on, then also the analysis wouldn't have changed much. Just the formulations would have changed a little bit according to the calculation. Okay, nothing much change would have been there. So just so that we can have a easy exposition or easy way of writing the answers and expressing the concept, we are not going into the advanced ways of defining the Lorenz curve, so to say. So fx is defined as the cumulative proportion of individuals having income less than equals to x. And let us say I define another ratio, f1 of x. It is basically the cumulative proportion of income earned by individuals having income less than equals to x. Okay, so the first one is what is the share of people who are earning that income, and the next ratio is what is that exact proportion of income that we are looking at. Okay, that means if I define f1, because the idea of f is very simple, f1 of x, it's basically you will sum all those income yi such that yi is less than equals to x, and then this thing will be divided by the total income, summation I running from 1 to n yi. This is what is the interpretation of f1x. The total income earned by individuals whose income is less than equals to x as a fraction of the total income. Okay, so now when you are trying to plot these two together for a society, so note one thing. fx also lies between 0 and 1, right, for all possible income values, and f1x also lies between 0 and 1 for all possible income values, right? So you start with 0 and both of them are 1. So the space in which you will be drawing a Lorenz curve is basically bounded by 0 and 1. On the horizontal axis, you will be plotting f of x, and on the vertical axis, you will be plotting f1 of x, right? So the Lorenz curve is basically when you plot f1 as a function of f. This is basically the definition of Lorenz curve. Now you will observe that it will be basically convex to the origin. It will always start from 0 and will converge at 1. Okay. Now let us have an understanding of what the points on the Lorenz curve mean. Now suppose I talk of a particular point, let's say 0, let's say this point, point A, where the horizontal axis is 0.1 and this point is something less than 1, that is 0.01, let's say. Why I'm saying that this will be lesser than 0.01? Because if you just draw a straight line joining the two diagonals, it is basically the y is equals to x line, right, the 45-degree line. So if this is 0.1, then the corresponding point on this will be 0.1. So since the actual Lorenz curve, which is this one, this is the Lorenz curve, is lying below, so it is 0.01. So what does this point A mean on the Lorenz curve? So this is basically interpretation. Now look at the horizontal component of it, 0.1. That means it's basically talking of the bottom 10% of the people. It's basically talking of the bottom 10% of the people who are in the society. So interpretation will be the bottom 10% of the people earn only 1% of the total income of the society. This is how the points on the Lorenz curve are interpreted. And it actually makes really very much sense in economic terms, because you can understand that when we are talking of inequality, it means that some chunk of people are getting a large share of the societal income, and the remaining bottom people are getting a very less amount. A large chunk of people who are very much having a lower income are having a large, very small share of income to their catering. So the lower the Lorenz curve as compared to this horizontal, this line, this black line that I've drawn, which many of you might be knowing, is actually known as the line of equal distribution or egalitarian line. So the farther away the Lorenz curve is from this egalitarian line, more unequal the society is. Because understand that if you have a point on this egalitarian line, that means the bottom 10% of the people are having 10% of the society's income, right? So that is a fairly equal distribution. But if any point is below that, that means there is economic inequality. So naturally, you can see that the Lorenz curve can very well depict the degree of inequality that is faced in a society. So the Lorenz curve is basically drawing f1 as a function of f, where f1 and f are defined in this way. The notations might have been different in your earlier case, but the interpretations remain the same. Okay, so this is, we have explained graphically the Lorenz curve as a measure of income inequality. So now let's move on to the next part of the question, which is part B. How would you derive the Gini coefficient from the Lorenz curve? So that's fairly easy. So Gini coefficient, part B. Now just to have you this part, so you can understand that, as I mentioned a few minutes ago, that the Farther away the Lorenz curve is from the egalitarian line, more is the degree of inequality, right? So this area is a measure of how far the Lorenz curve is from the line of equality, right? So it's often known as the area of concentration. Area of concentration. So what we have to do is that, so the Gini coefficient is basically defined as a particular ratio. Now observe one thing. Okay, let me just draw it over here. Let us not disturb that diagram over there. So this is my square that we have because it's same vertices, same edge width, and then we just extend it from this point to this point, right? So this can be Lorenz curve of a society, and the farther away the Lorenz curve goes, more is the degree of inequality. So what is the completely unequal situation in the society? When only one person, the most richest person in the society, has the entire income and the rest don't hold anything. So that means the Lorenz curve would coincide with the right side and the lower right edge and the lower edge of the box over here. That means this is basically a measure of the maximum possible inequality that you can have. So the Gini coefficient is basically the area of concentration in comparison to what is the maximum that we can have, which is basically this area. So that is, you can simply calculate it out. It's basically a right angle triangle whose base is 1 and height is 1. So the area will be half. Okay, fine. So this is basically the definition of Gini coefficient. Now if you look at this area of concentration, it's basically the total area of this right angle triangle half minus the area under the Lorenz curve, right? Whole divided by half. So you basically have 1 minus 2 times area under the Lorenz curve. So if you have data, then you can have calculate the proportions and get to it. If you have an income distribution, theoretical distribution, then this will be basically to find the area. It will be integration of 0 to 1 f1 df. So this is how you can directly obtain a Gini coefficient from any given income distribution, or if you have data, you will compute the proportions in a similar way and then go in for using appropriate measures. Since they have not specified in the question which form of the expression they want to express the Gini coefficient, we have just mentioned the idea on which we can build up the measure. Now obviously in case of empirical data, this will change slightly the expression, but the idea will remain unchanged. Okay, so that's it for part B of the question. Thank you.